Hello.
We will start class within a 5 minutes. Continuously student joining us, so that's why I am waiting.
Okay, ma'am.
So we'll start class at sharp 4:10. If you have any query, you can ask. Okay. What we have completed in the previous class. Which topic was the last topic in the previous class? I'm asking question class. Please respond. That means you all were not there. Achha, master method. Okay. So may I know the three cases of the master method? So may I know the three cases of master method which we already done in the previous class? No one knows. That means no one revised the previous session. So it will be very difficult for all of you to get the good marks in your in your exam. So it's my request again. Whatever you did in your class, you have almost 5 to 6 days to revise that class. So it's my request to do this thing at your home.
Okay, ma'am.
Within a minute, I will start the class. It's my request to all of you, kindly on your video so that I can take your attendance. Now from the next class, you all have to write your name as well as the last four digits of your roll number in the display name. Thank you so much. Okay, so let's start the class. So after method, we have three methods to solve a recurrence relation. The first one is master method. The second one is master tree method. And the next one is substitution method. We already discussed master method in the previous class. Now I'm going to discuss the tree method. After that, we will consider the substitution. Let's start the class.
Yes, ma'am.
Okay, ma'am.
So it's a unit number 4, solving recurrence. In this, we already discussed these things. We started in the previous class talking about the methods for solving recurrence relation. We completed with the first method, that is a master method. Now the next method is recurrence tree method. Master method and recurrence tree method is very, very important for the exam point of view. Oops. So here is some problem related to PDF that is uploaded in your e-Gyan Kosh. Don't worry, I have a PDF. I'm sharing that one. So you will get the complete PDF on your LMS. Again, I shared the wrong one. Yeah. So here it is. So now we are going to discuss the topic that is recurrence tree method. Right? So recurrence tree method, as per the name, that means we have to construct a tree, a recurrence tree, that is a pictorial representation of any recurrence problem. Right? So reading a paragraph and reading a English terms of a paragraph, that is very difficult to understand as compared to tables or a diagram. So that's why here we are trying to solve a recurrence with the pictorial representation that is known as a recurrence tree method. So here we are going to construct a tree. How we can draw or how we can construct a recurrence tree, we will discuss first, and after that we will take a one example and do the similar thing. So first, we all know that here is an equation of recurrence, that is Tn is equals to ATP divided by B plus Fn. Here we know the term of A, we also know the term of B, and after that Fn. Fn stands for the function value, right? So for solving or for creating a recurrence tree method, we have some steps. The first step is to make a recurrence tree of a given recurrence. First put the value of Fn at root node. So whenever you are going to create a root node, you always put the value of Fn there. For example, here the Fn value is n square. So I have to write n square on root node. How many child of this particular root node? It's depend on the value A. If the value A is 2, you have to create 2 child. If there is a value 4, you have to create the 4 child, right? And what will be the value of the child? That is n divided by B. Clear? Right? So here is light on. Here is Fn function. Here is the children, that is a number of child nodes, and the value is always n divided by B. Let's take one example and do the first step. So here is the example. Solve the recurrence Tn is equals to 2t n divided by 2 plus n using recurrence function. Right? So the first step here is to make a recurrence tree, you have to write the value of Fn at root node. So what is the value of root node Fn in this equation? What is the value of Fn in this equation? MCA, please respond. N, yes. So here we have to put the n on root node, right? After that, we have to calculate the value of A. We have to represent the value of A. So here the A is equals to 2. That means how many number of child we need? That is 2. And what will be the value of the child? That is n divided by 2. So here is graph. Any question, any query you can ask. Otherwise, I am going forward. So students, do you have any query? So I'm taking this silence as no, right? So we are proceeding further. So the next step for the same is, now we have to find the value of Tn divided by B by putting n divided by B in place of n. So that means in the next step, we have to replace n with n divided by B. Right? So here is n. Just put n divided by B here. So in our equation, we have n here. So we will write n divided by B. Here is Fn. So then we have to write here n divided by B. So we will get equation n divided by B square, and this is n divided by B. So here the root value is the Fn value, that is n divided by B. Here it is. And the children value is n divided by B square. So all the children value is n divided by B square. So this will be the second step of your tree. So let's go with the second step with the same example. So this is the value n divided by 2 in place of n divided by b. We put n is equals to n divided by 2. We will get n divided by 2 to the square plus n divided by 2. So the tree is just like this. Any question, any query you can ask.
Ma'am, can you please repeat this?
Okay. So I'm going to repeat the second step. Kindly listen properly. So in the second step, we have to find the value of t n divided by 2 by putting n is equals to n divided by 2. So here is a function 2t n divided by 2. So in place of n, we just write n divided by 2. We are putting n divided by 2 in place of n. So here is also n. We are again putting n divided by 2. So what will, if the root node is n divided by 2, so for that root node, we have a value for child that is n divided by 2 square. So here it is. Any query, any question you can ask. That means no query, no question. Okay, let's do the next step. In this way, you can express a tree one more level. That means you have to represent your tree at least 2 levels. Right? So here we go. 2 level, that means we can create a tree just like this. So in each and every level, we get the value n. The first level is n. The second level is also n. Why? N divided by 2 plus n divided by 2, that is 2n divided by 2. Cut 2 with 2, you will get n. Again, if you multiply all the 4 children, you will get the value n. And so on. In the last, there is some n divided by 2k, and at that place, you will get the value 1. Right? So the last is always equals to 1, 1, 1, 1. Till now, any question, any query you can ask. That means no query. Very nice. Things I'm teaching well. So the next step, now you have to find per level cost of a tree. How we calculate the per level cost? Per level cost is the sum of the cost of each node at that level. So every node contains n, 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 n. So the series is n plus till n. Right? So after creating this level, we have a cost n. For each and every level, n plus n plus n plus n. That means you have to add all these level values. Right? Now, I have a question for all of you. What would be the value of a binary search tree height? Anyone knows the complexity or the height value of binary? Log. Yes, absolutely right, Jayashree. So that means we have a root and we have 2 values, one left and one right. If the value is greater than this, we have to go for the left. If greater, we have to go right, or less, we have to go left. So that means these are the things that we need to understand. So here is similarly on the first, we got the node value is n. After that, the root node value is n divided by 2. So n divided 2, after the n divided by 2, we have a value n divided by 2 square, and the last one is n divided by 2 to the power k. And we already discussed in this diagram, the last level value is always equals to 1. So the last level may be something n divided by 2 to the power k. So n divided by 2 to the power k is equals to 1. So here we cross multiply the value, we will get n is equals to 2 to the power k. Now, whenever you got a value 2 with some power, you will always multiply log with both the sides, LHS or RHS. So here is log n and here is log 2k, power k. So when you are solving the log value, you have to put the power before the log. So here you will go log n is equals to 2 is equals to k log 2. Log 2 is equals to 1. You will get the value k is equals to log base 2n. So it is the level, the height of the tree. Right? So the total cost is level multiplied by height. So the level is n and the height is log 2n. So this is the complexity of this is a recurrence and the complexity of this problem. Any doubt, any question you can ask.
Ma'am, can you explain it again? This part only.
Okay. Any other doubt with this? How can be the each level value n only? Okay, so in each level we are getting some root. So if we have a 4 root, so that level value is the addition of 4 roots value. Because this is n series, n plus n plus n till n. So that's why the total cost is n there. I'm repeating once again the last level.
Yeah, ma'am.
So here so when we saw this tree, there is the last level, that value is 1, 1, 1, 1, 1 in some position, in the last position, right? So on what will be the value of n, or what will be the value of 2 to the power k here? We don't know, but we know the last value is always equals to 1 in a tree, right? So that's why here n divided by 2 to the power k is equals to 1. Right? Just do cross multiplication. When you do cross multiplication here, it will be n is equals to 2 to the power k. Right? Now we have to take log both sides. If we take log here, it will be log n. If we take log here, so here is log 2 to the power k. So put that k in front of a log. So you will get here k log 2. So log 2 is equals to 1 with the base 2. So here you got a value k and this is a log n. So that's why the answer is k is equals to log base 2n. Now the total cost is the cost of a series of each level, that is n, multiplied by the height. So the height is log n. So the value is n log n here. Any doubt, any query you can ask. That means no doubt.
No, ma'am.
Ma'am, how did we calculated the cost? The height was log 2n. Then how did the cost is n log 2n?
Anjali, can you speak loudly because I'm not able to understand. Your voice is not clear to me.
Okay. Now I was saying, how did we get a cost of equation? The height was log 2n. How did we calculate the cost? How is it n log 2n?
It means you have to multiply the total cost, that means the addition of each root on each level, and multiply by the height. So in each level we are getting n, so that's why n is there. And after that the height of the tree is log n, so n multiplied by log n.
Okay, ma'am. Thank you.
Any other question? Okay, so we completed with the master tree method. So you will definitely get master method or recurrence tree method in your question paper.
Excuse me.
Yeah.
Can we see the implementation part? Means how we can implement this thing in programming?
How you can implement with this. So for solving a recurrence function, for example, this is a recurrence function for which
Sorry ma'am, sorry for interruption. Let's take an example of factorial one. We can implement through recursion. So let's implement tree method in that. So just show us with that.
if you know the recurrence method,
Yeah, ma'am.
if you know the recurrence equation, you can easily perform the tree method.
Yeah.
So you need to use, if you want to solve a recurrence tree method, you need to create the recurrence method of the particular problem.
Okay.
So maybe it's factorial, it's prime number, so it's depend on your problem. So after getting your problem, you need to convert into a recurrence equation. After that, you can implement master method or a recurrence tree method.
So basically, in a linear way, means whenever we are talking normally about recursion method, so we are just simply calling the method itself one after another at the end of the code. Okay. So how we can implement this thing through this tree method? Means how it is different from the basic to this one.
Similarly, I'm saying there is a limitation of a master method.
Yeah.
Right? So if we are talking about a master method, so if you are getting the recurrence, that is 2t(n minus 1),
Yeah.
not n divided by 2, n minus 1 plus some function number. So that is not a problem that will solve by master theorem. So here is a problem. So you can use a master tree method here to solve your problem.
Okay, so means the problem should be like that, then we can implement the thing there.
Yes, if you need a recurrence equation, if you have a recurrence equation, you can implement these methods. For example, I have a binary search algorithm, and the binary search algorithm recurrence value is 2t(n divided by 2), and some function is n. So that means this is a recurrence relation. So I can implement any method from these to solve the recurrence.
Okay.
Any other question?
Thank you, ma'am.
So substitution method, I think in previous class we completed this.
Ma'am, you have described a little bit, so
Okay.
let's go with
So I'm explaining it again. So in a substitution method, you need to do two steps. The first number is guess the asymptotic bound of the solution, and the second number is prove the correctness of the guess using mathematical induction. So here is solve the recurrence by using substitution method. So here we have. So what do you mean by n divided by 2 here? I already discussed this thing in the master method. What do you mean by n divided by 2 here? MCA, please respond.
binary.
Ma'am, it is the value of an.
One by one. Vishnu, please.
Yeah, ma'am, the problem should be binary then.
Divide a problem into subproblem.
Yes, Imanshu, absolutely right. When we are dividing a problem into a sub-problem, like we are dividing the first problem into a two-part, then again into a two-part. So that's why we are here n divided by 2. right? So merge sort algorithm always do the similar thing, and the complexity for the same is n log n. N for the n terms value and n divided by 2, that is log n. N divided by 2 means we are dividing the values into two parts. So here function less than is equals to CGN. If you read this equation, so this equation is, which equation is this? Fn is less than and equals to CGN. Which notation function is this?
Asymptotic.
Sorry,
Asymptotic notation.
which asymptotic? We have a 3 asymptotic notation.
And theta.
No. Here it is. Here it is. We guess our value, that is big O and log n. And the big O equation is Fn less than and equals to CGN. Right? So big O notation equation is Fn is less than and equals to CGN. So here we are using big O, that's why we are using this value here. Right? So for the 1, we have to write n is equals to 1 here. So 1 log 1. Here in the second step, we have to write n is equals to 2 here. So n 2, 2 log 2, and here 2 divided by 2 t1. So t1 value is 0. So 2 multiplied by 0 is equals to 0. 2c is less than and equals to 2c. Now for the next step, we have to consider n is equals to n divided by 2. So here we have a value Tn is less than and equal to, so 2 is Tn is less than and equals to Cgn, and the Gn value is n log n. So in place of n, we have to write n divided by 2. So here is n divided by 2, n divided by 2, n divided by 2. Right? So here we will solve this problem. So here is the log n divided by 2. So whenever we have a value in log with division, we can subtract it. So we can write here it Cn log n minus में Cn log 2, because 2, when we multiply 2 into c n divided by 2, we will get 2 with this number, we will get cn here. So cn multiply with log n first, then cn multiply by log 2 with subtraction sign, and this plus n as it is. Log 2 is always equals to 1. So here we can neglect the c value because this is a constant value. When we subtract n into n, so we will get the value n log n. Kindly read this step. Give me a 1 minute. After that, I will take your queries. Just go through these steps. Yes. Any doubt?
मैम समझ में नहीं आया.
Okay, I'm explaining once again, but you need to understand after solving by yourself. You need to do a practice of this. You can understand after the practice.
Yeah, sure.
Right? So here n is equals to n divided by 2. So we have an equation. So what is the value of equation? Tn is less than or equals to Cn log n. So we are going to put n divided by 2 in place of n. So it will be n divided by 2. This is C n divided by 2 log n divided by 2. So here is value. Right? Now, if we are talking about a Tn value, so what will be the what is the Tn value here? For the Tn here we have one equation that is 2Tn divided by 2 plus n. So here it is. 2Tn divided by 2 plus n. Right? So now we have a value. What value we have right now? This value. This value is equals to Tn divided by 2. So here we have Tn divided by 2. May I put this value in place of this? Yes, I can. So that's why the value is here. We just replace Tn divided by 2 with this value. So put this T value in place of this and you will get the value this. Any doubt till now?
No, ma'am.
When you multiply 2 with this equation, so this 2 cut with this 2 because it is multiplying and it is dividing. Right? So we will get Cn log n divided by 2 plus n. We all know that whenever we have division in log equation, that is equals to the subtraction of that two numbers. So I can write Cn in the bracket log n minus log 2. So I have to multiply Cn with log n and Cn with log 2. So here it is. Any doubt till now?
No, ma'am. Clear.
Now, what will be the value of log 2?
1.
1. So, what we have the remaining value, that is Cn log n minus Cn plus n. So, we always neglect the constant value. So, I can neglect C here. So, this is minus n plus n. It will be cutted. So, what we have left, that is n log n. So, here is big O n log.
Okay, ma'am.
Now, any doubt?
No doubt.
No. Okay. Now, with this method, yes, you have to assume 1, then 2, and then n divided by 2. Here you have to solve the 3 steps. Right? So, with this method, we completed with our block 1. Now, I'm going to start block 2. This is block 2, unit 1, greedy techniques. So what do you mean by greedy techniques?
Greedy means greedy, lalchi.
Bilkul. Okay, yes, that means if we are talking about the Hindi meaning, that is largely. So
Yeah,
it is, we have to take a value that will give you a maximum profit or a maximum quantity with the optimal utilization of resources. So that is known as a greedy technique. So whenever we are going to start reading greedy technique in any book, we will get a coin question always. I'm getting some noise from some mic. So it's my request to mute yourself, please. Thank you so much. Okay, we always get a maximum profit with minimum cost with the optimal solution. That is known as a greedy technique. So here are some more examples to understand the greedy technique. So here, consider a bus which can travel up to 40 km with full tank. We need to travel from location A to location B, which has distance to 95 km. So A to B, we have a total distance that is 95 km. So in between A and B, there are 4 gas stations, that is G1, G2, G3, G4. Which are at a distance this from the location A respectively. The problem is to determine the minimum number of refill needs to reach the location B from location A. Right? So here is so many gas filters. That means where we can go and fill the tank. So suppose the tank refill decision criteria is considered to refill at the gas station which is nearest when the tank is about to get empty. So according to the criteria, we are starting from A. So the tank will be refilled. So this is 37. The first is the tank will be refilled at the second gas station, that is G2. Right? So from G2, it takes 37.5 kilometer. After this, we need to refill at the 4th gas station, that is this, from G2. So we can reach at the location this as it is 20 kilometers. Right? So you need to understand, you take a very less resource and get the optimal solution to get your destination. If you didn't understand the example, we have a next example. Let's take it. To illustrate the same, consider a list of a job given in the table. In this problem, second row represents the time taken to accomplish the corresponding job. The problem is to count maximum number of jobs that are possible in the given time limit. T is equals to 6. Right? So here total number of job is 5. So N is equals to 5. So now the problem is count maximum number of jobs that are possible in the time limit 6. So if we consider the J3, right? So if we are talking about a J3, it is, I will give the 1 time to it. So if we are doing the J3, that means add this solution to the set. If J3 is here, remaining time limit is 5. Right? Because the J3 is getting a very less number of time. So that's why we consider J3 here. Now the remaining is J1, J2, J4 and J5. Again, which is taking the minimum number of time, that is J4 here. So we consider J4 here. Now the remaining time limit is 5 minus 2 because J2 is taking a time 2. Now we have 3. So again the minimum is J1 with the 3. Now my time is complete. I cannot take any other job. So the set is J3, J4 and J5. Right? Now the next one. So on the above, we can't divide the time and we can't do fractionalize the thing. But the next method here is fractional knapsack. Right? So if we are talking about a fractional knapsack, that means I can fractionalize the thing. If there is a 3 fruits and I have a packet that takes only 2.5 fruits, so what I have to do, I can collect the 2 complete fruits and the next one is half. That means I can fractionalize that thing. So that is known as fractional knapsack problem. In a fractional knapsack problem, we always have a next step, and we have to think about a thief. That means whenever we are going to theft somewhere, what things we have to collect. For example, in a room, there is one mud bowl and the one bowl that is made from gold. So which will be theft by you? That bowl created by a mud or the bowl created by a gold?
Gold one.
It's gold one.
Gold one, right? So here you have to think just like a thief. So here we have a formula. What will be the formula? Give a list of n objects, say O0, O2, On, and one knapsack. Whenever we use a object, we always use a notation O. And a knapsack, capacity of a knapsack is equals to W. W stands for a weight, for a capacity. Right? So here we have for example, consider one example. Number of object n is equals to 3. We have number of object that is 3. And we have a knapsack. That means अब वो हम लोग बोरा जिसे बोलते हैं जिसमें काफी सामान भर के लेके जाते हैं. So the capacity of that knapsack is equals to 20. And here is the profit. P1 for the first object is 25, P2 for the next object is 24, and P3 for the third object is 15. And here is the weight. For the first object, weight is 18, for the second 15, and then 10. To solve this problem, we need a greedy method may apply any one of the following strategy. If first strategy is maximum profit. You need to theft those things that will give you a maximum profit. Next, minimum weight. That means theft that things that has get a minimum weight thing so that you can get a maximum number of any product that you are taking. The next one is maximum profit divided by weight. You have to calculate first the profit and the waste and the weight, then get that object. Right? So let's discuss the first one. So here is object. This is object x1, x2, x3. Right? We have to calculate weight multiplied by object. Then we have to calculate profit multiplied by object. Here we have 3 objects. So that's why I is equals to 1 to 3. So let's start the question. I'm taking a screenshot of question so that you can understand the solution as well. Are you able to see my both screens?
No, ma'am, only one screen is visible.
Only one screen. Again, it's an important question. Here we go. So again, we have a 3 objects. According to question, we have total 3 objects. Hello?
Yes, ma'am.
So we have a 3 object, that is n is equals to 3. Right? So here we are, we have 3 objects that is x1, x2 and x3. Now, the capacity of knapsack is equals to 20. So according to this, we have a less weight of object first, that is 18. So I have a knapsack that has 20. So I can take the first complete object, 18 kg, right? So here we go. So the first object I completely picked. So that's why here is 1. The weight of the object is 80. Right? Now what is the remaining weight of knapsack? What is the remaining weight of knapsack now?
2.
2. But the weight of another 2 objects are 15 and 10. Right? But here we are doing maximum profit. So that's why we are not considering weight here. We are considering profit here. So maximum profit is 25. So we take the first one, that is 18 kg. Now the maximum profit is 24. So I will take a 2 part from 50. So that's why here is 2 divided by 15. Now my knapsack weight is complete, that is 20. So I will not take the third part. So that's why 0 and 0 here. Any doubt? Udhar ho gaya? Any doubt?
Ma'am, how we selected second part? 2 by 15?
Okay, you the first approach we are doing, in a first approach we are taking, select the object with maximum profit. So if we are considering the profit, maximum profit is 25. So that's why I picked the first object and the weight of that object is 80. So here it is. I picked the complete object, that's why I write 1 here. And after that 18 is the weight. Now, the remaining weight of the knapsack is 2 and the maximum profit of the object, second object. So I'm not able to pick the 15 weight object because I don't have a capacity in my knapsack, right? So that's why I'm taking 2 from the 50. Let's take kg. So I'm taking a 2 kg from 15 kg. Now my knapsack is full. So that's why I'm not taking the third object. That's why here is 0 and 0.
Yes, okay, right.
Right? Now, how to calculate a profit? So how you calculate a profit? P multiplied by X. That means profit multiplied by object. So here 25 multiplied by 1. So you will get 25. Plus the next object is 2 by 15. So here 2 divided by 15 multiplied by profit. So the profit value is 24. The next value is 0 multiplied by profit. Profit is 50. So you will get the total profit this, that is 28.2. It is saying profit multiplied by x. X means object. Here is the x value. So profit for the first is 25. Then multiply by 1, you will get a 25. In the next, 2 divided by 5 multiply by 24. And next 0 multiply by 15, you will get 28.2. Any doubt you can ask. No doubt?
No doubt, ma'am.
Okay, the next one is minimum weight. Minimum weight, that means we have to consider the weight now. So what is the minimum, which object has minimum weight? That is 10. Right? So I pick the complete with 10 weight. Now the remaining weight of my knapsack is 20 minus 10, that is 10. Now the minimum weight is 15. I can't take the 15 kg in my knapsack. So I have a remaining capacity, that is 10. So I will write 10 divided by 15, that is equals to 2 by 3. I can't take the first object because I don't have a capacity in my knapsack. So here 0 plus 10 plus 10 is equals to 20. Again, we will do the similar thing to get the profit. That is 0 multiply by 25. Then 2 by 3 multiply by 24. And 1 multiply by 15. I will get the value 31.0. Similarly with the next. Next is maximum P divided by Pi divided by Wi. That means 25 divided by 18, 25 divided by 15, 15 divided by 10. So I think so you will get this is something for 1.4. In the next you will get 1.6. And in the next you will get 1.5. I'm not sure, but when I did calculation in the previous semester, so I think so this will be the value. So the first one is 1.4, 1.6 and 1.5. So that means I have to take the maximum. Maximum is 1.6. So that's why here we take the complete product. So here it is 15. For the next, we have a 5 remaining capacity, and the next one maximum is 1.5. So I will take 5 by 10, that is 1 by 2. So complete the knapsack and the profit again the similar. Any problem, any question you can ask.
No problem, no question.
What will be the optimal solution? From
I think first one 28.
Okay.
No, ma'am. Profit by weight ratio is optimum solution.
I
Profit by weight ratio because it give maximum profit.
yes. So greedy approach may not allow yield an optimal solution. In such cases, the greedy method is frequently the basics of a heuristic approach. Sometimes a clever strategy can indeed lead to optimal solution. So that's why we always use the maximum profit as a maximum solution. What you need? क्या चाहिए आपको? मेरे पर्स में से ले लो. Got it? Here you have some examples. So it's my request to all of you, kindly do that examples. Now the next one is task scheduling algorithm. We are talking about the task scheduling algorithm. A task scheduling problem is formulated as an optimization problem in which we need to determine the set of a task from the given task that can be accomplished within their deadline. So that means we have a schedule here in our order and we have a deadline with that. So we have to complete that task to maximize the profit. So optimization problem with a constraint that task must be completed within their specific deadline. So let's take one example. Let us consider an example to understand. Suppose there are 5 tasks and each task has associated profit and rupees. You have a task here with profits and deadline. So the amount of time required to complete each task is 1 hour, right? So the deadline of each task is given in this table. So whenever we have to solve this problem, consider the highest deadline and prepare that many number of slots of unit time to schedule the task, right? Okay, so according to this problem, we have the highest deadline that is 3, right? So here it is. So if the deadline is, the highest deadline is 3, so there will be a 3 slot. Each slot of 1 unit, like 0 to 1, 1 to 2, 2 to 3. Now, greedy approach has to select the set of 3 tasks and schedule them in such a way that the total profit of maximum on their completion. So according to this criteria, task T2 is selected and placed it is in the slot closest to its deadline. Right? So if you completed the task 2, you will get a maximum profit with. Right? So the selection criteria will be to select the task with highest profit. So according to this criteria, which task you will take first? That is T2. Now the next task, what we have to select? We have to select the T1. Right? So the next task T1 is selected from the remaining set of the task according to the selection criteria. So the deadline for task T1 is 2. But we have already scheduled T2 in the slot 1 to 2. So we have to look for an empty slot before this slot. So the 0 to 1 slot is empty. So task T1 is placed in slot 0 to 1. Now the next with the highest profit is T4. Right? So the appropriate slot for T4 is 0 to 1. So again, according to the deadline, it is appropriate, but it's already filled. So there is no other slot before 0 and 1. So this task is not scheduled. Right? Similarly, we have to do all these things. So again, we have to select T5. So we have to places in places of 2 or 3 slot because it has a deadline of a 3. So now we can't do this because there is always one, that is T4 here. So that's why we get the profit 18 plus 22 plus 7. T1 value, the maximum profit, and T2 value, the maximum profit, and T4 value, the maximum. This is your check your progress and Huffman code. If we are talking about a Huffman coding, it is a greedy technique algorithm that is used to compress the data. Data can be sequence of a character, and each character can occupy multiple time in a data. That is known as a frequency of that character, right? So let's take one example. Whenever we take any character, there is some ASCII and binary form, right? So whenever we calculate the Huffman, we always know the binary and the ASCII value. For example, whenever we talking about a 1 bit, so 1 bit contains the 2 character, that is 1 and 0. 2 bit contain a 4 character, that is 0001 1011. 3 bit contain a 3 character, that is 000. So according to that, the character A, if frequency will be given by a question in your question paper. So here is your frequency. You will know the code. So this is a code, and multiplying both the things, you will get the total bit or a character. So here is Huffman coding makes in 2 steps. The first is build a Huffman tree, then find the Huffman code fit for each character. How you can build a Huffman tree? Here is a step for building Huffman tree. Input is a set of M character, and each M has a frequency, M frequency. Store all the character in minimum priority queue using frequency as their value. So in data structure, you know the priority queue. You can make it for min or max, just like a heap tree. Insert it, delete as per min or max. If a heap is used to implement priority queue, so you will always take a log n time. Exec to minimum node x comma y from min priority queue pq. So just leave this. I am taking and I am making by using an example so you can understand better. For example, we have a value A70, B is equals to 2, C is equals to 5, D is equals to 13, E is equals to 3, and F is equals to 7. Build a minimum priority queue based on the frequency. So I just write all these values in ascending order. So here 2, 3, 5, 7, 13, and 17. Now I added both the values. So here is 2 and here is 3. For the addition of both the values is 5 here. So build a minimum min priority queue based on the frequency. Initially here the value is 6. So each node represents the node of a tree with single node and required 5 merges to build a tree. So if you have a 6 letters, you will get a n minus 1 merges, right? So here extract 2 minimum nodes x and y. So we have a 2 minimum node 2 and 3. And internal z having the frequency. So we have a 2 plus 3. We will get a z value 5, right? Now the next one is the z value is 5, right? Now the c value is also 5, right? So add 5 and this 5, except 2 minimum node. So here 2 minimum node is 5 and 5. All are greater than 5. Right? So here we can add 5 plus 5, 10. Now the next node is Z value is 10, F is 7, 13 and 17. Now again we have to pick 2 minimum nodes. So here is 10, here is 7. These are 2 minimum nodes. So we added 10 and 7. Right? So again we have 17 and we have 13. Then A is for 70. Now we have to pick again the smallest. It is 17 and 13. We will get 30. And again, in the last, we have a 70. We added 100. Right? Do remember, if you are adding two small number, your left value is always small and your right value is always greater. For example, we have a value 7 and 10. So you can't write 7 here and 10 here. So we build the Huffman tree. Now we have to get, okay, if you have any question, you can ask. Otherwise, I am proceeding with the next step, that is a Huffman code corrector.
Ma'am, what's the importance of Huffman code?
So it will give you a minimum time to calculate a particular code for any equation.
Means execution time.
Yes, you can say. Okay, let's generate the code. For right, you will get 1. For left, you have to write 0. So for A, this is on right. We will mark 1 here. So yeah, just a minute. I'm taking the. Here. For the right, always take 1. For left, take 0. So here is 1. For A, the code is 1. Next, this is 0. Then again write 1, 1, 0, 0. So here is the value 0, 0, 1, 1, 0, 0. For a C, where is C? Here. So this is 0, 1, 1, 1. So here is 0, 1, 1, 1. For D, this is 0, 0. So here it's 0 and 0. Right? Similarly, for the other values, you have to calculate the total bit. How you calculate total bit? Frequency multiplied by 4. Right? The value of the code is 3, 4, 5. So 5 multiplied by 3. This is 4. 4 multiplied by 5. So here is mistake with the second part. So next one is 2. 2 multiplied by 13. This is 5 multiplied by 3. And this is 3 multiplied by 7. With this, we completed our unit number 1 of block 2. So I'm giving you a 3 minutes. Just have a look of Huffman. So after 3 minutes, I will continue with the unit number 2. And we will complete unit number 2 today.
Okay, ma'am.
Have a look in your PDF or whatever you have a study material of it in any form. So let's start the next unit. So now block number 2, unit number 2, that is divide and conquer technique. We completed with the greedy techniques. Now we are proceeding to the next topic, the next unit, that is divide and conquer technique. that give you a optimal solution also. So if we are talking about a divide and conquer, so what do you mean by divide and conquer technique?
We will divide the problem into sub-process. We can say as a sub-process until it is not divisible or maybe it's solvable. Means we can solve that. Until that, we just divide it.
Then, what do you mean by conquer?
So here the meaning is as it's described that each unit should be solvable until we consider that one as a concur one.
Yes. So that means we have to divide a problem, conquer it, and combine it. Right? This is the 3 steps of divide and conquer. So we can take an example of divide, that is a merge sort divides the array of an element into a n sub-arrays, where each sub-arrays contain only one array. Right? After that, we have to solve that and then combine. So again, recurrence if we are talking about the recurrence relation formulas in divide and conquer, it's divide the similar thing. Divide, conquer, and combine. Right? So dividing, you are dividing that into a part. So that's why it is always take n divided by p. Tn stand for required time to solve a problem. Tn is the sub-problems, right? So time required to divide and conquer is divide the problem and combine the solution. If the problem size is small enough, so you will get a constant time. So constant time that contain a θ1. Divide a problem of a size n into sub-problem, you will get 1 by b size always. So let's start binary search. We already discussed the linear search. So what do you mean by linear search and how is it different from binary search? Which search is better?
What, ma'am?
Which search is better, binary search or a linear search?
I think binary search.
Okay.
Actually, in linear search, there is no limitation. We will go further at the end of the node, means or the element. But in binary search, there is limitation. We have to divide it properly, one after in 2 groups. Again, sub, we are going like this. So there is a boundary in that.
Okay. So here in the linear search, we have to compare our search value with each and every element of an array. But if we are talking about a binary search, in this, we will search the value after dividing the array into 2 parts. That means we have to divide first. So when we get a 2 sub-arrays, so we will test the key value is smaller than the middle value. So I have to go to the left part. If greater than the middle value, I have to go to the right part. Right? So then conquer it and give the result. So let's take one example. Consider a sorted array. Do remember, binary search always do on sorted array. Linear search can be do on any array. Maybe it's sorted and maybe it's unsorted. But it will be applied on sorted arrays only. Binary search will be applied on sorted array only. So here we have a sorted array. Now the key element that we have to search is 26. So now we have to calculate the middle value. So 0, 1, 2, 3, 4, 5, 6. That means the lower index value is 0 and the upper index value lower is 0 and the upper is 6. So we have to calculate middle. 0 plus 6 divided by 2. So we will get the value 3. So the third index value we have to put, that is 24. 24 is not equals to 26. That is smaller than 26. That means the value will be found on the right hand side. So we have to consider the right side elements only. Right? So now the middle will be middle plus 1. So it will be the fourth element. 4 plus 6 divided by 2, that is equals to 5. So we have to consider the fifth element. Now, if we are talking about middle, so middle is 27. Again, if we are comparing, that is less than, we have to go to the left hand side. So here mid minus 1, so mid is here. Then again mid is 1, 2, 3, 4, and the value is also 4. 4 plus 4, 8. 8 divided by 2, that is 4. Fourth element value is 26, that is equals to key value. So we found that our element is on fourth position. What will be the complexity of binary search?
Log n.
Log n, because each time we are dividing our elements into two subparts. Now we have some sorting algorithms here. The first one is merge sort. In merge sort, we have an element we have to divide into two parts till when we get the individual elements, right? So that means divide and conquer approach to perform sorting, right? So in this array into two equal sub arrays, take the first element of both arrays and compare them, then conquer it and combine it. We have example here. This is 37, 20, 23, 30, 18, 15 until now. So in divide step, the array is divided into two subparts. So we divided into two subparts. Then we have to conquer it. That means we have to compare each and every element. In the last, we have to combine both the elements. So here is a list of n elements. So 98, 23, 45, 40. So here we have to divide the element into two parts, 98, 23, 45, and 40. Now we have to compare all the elements one by one. 28 and 23. So 23 is less than, we have to swap both the values and merge it. Again with the 14 and 45, in the last we will combine all the values. So it will take n log n time, because first we are dividing each and element one. So that's why that means we are go through each and every element, right? After that we are merging. That means we are taking log n times. So it is a recurrence equation for a merge sort. It is also solved by master method and recurrence tree method. So it's my request to everyone, kindly go through these equations with both the methods. Now the next one is quicksort, where we have one pivot value and we have to calculate it. Just give me a minute. So I have a best example for a quicksort. Here is a step-by-step process. Consider the first element of the list is pivot. You always consider the first element of the list is pivot. Define two variables, I and j. Set I and j. I is the first and the j is the last element. Now, increment I until list of I is greater than pivot. When list of I is greater than pivot, then stop. Decrement j until list of j is less than pivot, then stop. If I is less than j, then exchange the value of list I and list j and repeat this step. So let's do one example. Here we have a list 5, 3, 8, 1, 4, 6, 2, 7. Here we consider the first element as a pivot element. Left the value is 1 and the right value, that is the last. Right? Now we have to compare the pivot value with the leftmost value. If list left is greater than list pivot, then stop left, otherwise move left to the next. So this is greater than this, no, just move. So our left is on which position? 8. 8 is greater than which value? 8 is greater than pivot. So here it is. Here is the greatest value. So we have to compare. If list left is less than list pivot, as it is true, increase left by 1 and repeat the same. So here left stop here because here left is less than pivot. Now compare the right value. Right is greater than pivot, as it is true, decrement right by 1. Right? So here this is the right value. Right? So right is greater than pivot, you have to decrement it. So decrease it, right is here. Now the right is smaller than left. Both the values are here, this value is true. Then we have to swap both the values left and right. So here is a true 2 and here is 8. Do the similar thing with the left. So here the left value is greater than pivot, no. The left value is greater than pivot, no. The left value is greater than pivot, yes. Stop left here. Now do the right. Right is smaller than pivot, no. Right is smaller than pivot, yes. Stop here. When the left value is, here is the situation. If both left and right stop, but left is less than right, then swap left and right and continue the process. But if left is greater than and equals to right, then swap the pivot with right. So here is left is greater than right. Left is greater than right. So we have to swap the right and pivot value. So here we have 4 value and here we have 5 value. Now both the two are the different lists. Here we observe that all the number of the left side of 5 are smaller and the right side are greater. That means 5 is placed in its correct position. Now we have 2 lists here, this one and this one. We consider these 2 lists individual lists and perform the similar step that I performed in the previous list. And in the last we will get the complete solution. So this is our Quicksort. You must have to read each and every topic so that you can clarify and can ask a question in the next class. So here, a master method and recurrence for the same Quicksort. Now we have integer multiplication. Okay. Integer multiplication, that means if we have a two integers 1024 and 3672. So we have to multiply both the integers. So it is very difficult task to multiply both the integers, right? So what we have to do, I can write any integer into two parts. If we have an integer 657,138, I can write 657 multiplied by 10 to the power 3 plus 138. Similarly, here we can write 6578 multiplied by 10 to the power 3 plus 381, right? So here is a Karstupa method that will help you to calculate this integer multiplication, and here it is. So here is the master method for the same integer multiplication and the substitution method also. So it's my request to do all the terms in your homework, because I already completed how to solve a master method, how to solve a substitution and tree method. So I'm not wasting time to do all the methods of all the terms. So you have to do by yourself. Now the next is matrix multiplication. What is the rule to multiply two matrices? What is the rule to add two matrices? Good morning, MCA first.
Good morning, ma'am.
Good morning, ma'am.
Why you all are not giving answer?
Okay, just simply each element of एक एलिमेंट दूसरे मैट्रिक्स के कॉलम से मल्टीप्लाई
The
करके
number of rows of the first matrix, if number of rows of the first matrix is equal to the number of columns of the second matrix, then we can multiply both the matrices, otherwise not.
Yeah, thank you, ma'am.
All are sleeping, right?
No, ma'am, you are giving a good lesson.
No.
This is an evening time, so maybe all are taking nap. Okay, this is the last topic. After completing this topic, we will definitely close this session with the completion of unit number 2 of block 2. In the next class, we will do the block number 2, unit number 3. And block number 3, unit number 1. Both are very interesting topic. That is a graph theory. this is our 4th class. Am I right?
Yes.
Yes,
So
ma'am.
we have 2 class left. In the next class, we will done graph theory part 1 and 2. And after completing this, we have remaining part, that is unit number 2 and 3 of block 3. That is Manchester algorithm and dynamic programming technique. Right? So in the last class, we will do unit number 3 and unit number 2, and we will discuss the question paper, how we will get a question of a particular topic in our question paper, how to write your answer in question paper. So we will discuss all these things in the last class. So it's my request to everyone to present in the last class.
Okay, ma'am.
Okay, ma'am.
Okay.
So here is a straightforward method. If we want to multiply 2 matrices, we have to multiply this value with all this and this value with all this and get 2 values here. That means the next matrices, right? So here we have a divide and control strategy for multiplication. This is developed by with scientist Stayerson matrix multiplication. So when we multiply with a loop with the above pattern, the complexity is n cube. But while applying the Stayerson algorithm, we will get the value n to the power 2.81 complexity. This is 2.81. I'm right. So what you have to do, you have to divide. This is a Stayerson algorithm. You have to divide your matrices into 2 parts. You have to calculate 7 sub matrices. So here it is. So here you have to divide your 2 matrices, that is n into n matrices. So you can divide into these 7 parts. You can calculate these 7 parts, and after that you have to combine these 7 parts according to the C value. That means the solution matrices. So you will get C11 value, C12 value, C2 value, C21 value, and C22 value. So for example, here we have a 2 matrices, right? So first we have to divide this matrices into 2 parts. So here A11 is 0206, A12 is 3403, right? A21 is 4103, A22 is 1250. Similarly with the B values. Now you have to compute with these patterns. So you have to calculate these patterns. That means P1 is applying by A11 plus A22 multiplying with B11 plus B2. With the similar, all the values you have to compute here, all the P's value. So when you compute all the P's value, you have to calculate C's value by adding and subtracting these P's values. Right? While you are performing the simple matrix multiplication using a mathematic formula, you have to do a number of multiplication, number of additions. But here you are doing a limited number of multiplication. 1, 2, 3, 4, 5, 6, 7, 8. Only 8 multiplication is here. Right? So in the last, you will get the complete solution of your matrix. So this is all about matrix multiplication, Stayerson matrix multiplication. We completed with unit number 2 also. So it's my request to all of you, kindly go through all the units, all the topics, so that you can take your queries and ask in the next class. So it's my request to all of you, kindly on your video so that I can take your attendance. Thank you so much. If you have any queries, you can ask. We have a 5 minutes.
Attendance has done, right, ma'am?
Sorry?
Attendance has done, right?
Yes, it's done.
Okay, thank you.
Attendance is done. If you have any query, you can ask. So that means no query. Thank you so much. I am winding up this session. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thanks, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.